welcome you back to the geography classes of Careerflite, and today we are going to discuss the second part of the geomorphic processes. In the last class we have discussed about the geomorphic processes up to weathering, and today class we are going to continue the class from mass movement, then erosion and soil formation. So if you like the video, please share the video and subscribe the channel. The last time we talked about up to weathering. I hope things are clear to you till now. What is weathering? Weathering is the mechanical disintegration and chemical decomposition of rocks. So in weathering, many processes acts together. They are biological, physical, and chemical. They act together to break down the rock. And next, over the weathering particles, erosional agents will work. The erosional agents, they will bring these fragmented particles. The result of the weathering is fragmented particles, rocks. These fragmented debris of rocks will be brought by river or other glacial like groundwater. All these erosional agents will bring these fragments from one region to another region. It will deposit it here. Okay, and this process will be done by agents, geomorphic agents. Geomorphic agents. Now, what are the geomorphic agents? They are river, glacier, groundwater, waves, and currents. Now, who are the geomorphic agents? They should have the capacity. Geomorphic agents are the agents that can acquire and transport something from one place to another place. And for example, the best examples are running water, glacier, wind, then currents, and waves. We can find effect of currents and waves in the coastal areas. The waves and currents you can see over the sea, over the ocean, sea and water body. Then these currents and waves, we can see the effect of currents and waves in the coastal area. When these waves and seas, they bring this energy and they hit the coast area, then they can show some deposition and erosional features. Then again, wind we can mostly see in areas where there is the areas which are lack of vegetation. There is no enough vegetation, like in desert areas. This geomorphic agent, wind will be more effective in the desert areas. The glacier, we can see the effect of glacier in the mountainous area where the glaciers are formed. Then again, running water, all over this plain area, starting from the mountains when the running water starts, starting from the mountains where the water starts, within this plain area and up to the coastal area near the delta area, you can see the effect of running water. So these are actually geomorphic agents, and what they do erosion and deposition. Erosion and deposition means they erode the surface of the rock, this surface. Okay, so one thing you have to know that weathering is not prerequisite for erosion. Weathering is not prerequisite for erosion. So erosion can take place from a rock eroded material. This running water can erode this surface of the rock and they can bring it and deposit in some other place. For example, running water. Okay, running water is eroding this rock surface and it is bringing it to some other place and depositing it. Okay, that is the process of erosion. So weathering, whether weathering has taken place or not, it is not concerned for erosion. Erosion will take place, but this weathering will aid. It will aid the process of erosion. It will help to increase the rate of erosion because of weathering. These are in fragmented particles. They are now in fragmented state. So this fragmented state will be easy for the erosional agents to bring these fragmented particles from one place to another place. So weathering is not a prerequisite. तो वेदरिंग नहीं होने से भी इरोजन हो सकता है, लेकिन वेदरिंग होने से स्पीड और बढ़ जाता है इरोजन का. So next we are going to talk in detail about erosion. Now what is the force responsible for erosion? It is इरोजन के लिए कौन सा फोर्स चाहिए? Actually, the erosion of a agent, of an any agent, the erosion of any agent depends on the speed of the agent, speed and mass of the agent. What is the weight of the agent and how much fast it is moving? The amount of the magnitude of weight and the speed, or you can say velocity. So, erosion you can measure through the energy called kinetic energy. Okay, kinetic energy, and I have already explained in last class what is kinetic energy. Kinetic energy is the energy due to the movement of a particle. Okay, it is the energy because of the movement of the particles, molecules, anything, whichever is moving in a particular direction, from in a horizontal or vertical, that moving particle will have an energy with it. And this energy is nothing but kinetic energy. And the kinetic energy of that moving particle depends on the mass and volume. Kinetic energy is equal to half mv square. Here, mass is the weight. It is the weight, mass of the particle, and v is the velocity. Okay, v is the velocity means speed. So movement, the erosion, how much erosion an agent will do depends on the kinetic energy, how much kinetic energy it possesses, how much kinetic energy this geomorphic agent possesses, and it will depend on the formula half mv square. So if you see them, if we apply this formula in the different geomorphic agents like running water, glacier, then wind, everywhere, if you put it here, you can see mass. If you apply the mass first, you can say running water, glacier. If you compare the running water, glacier, and wind, running water, glacier, and wind, you can say that wind have the less mass, very less. The mass of the wind will be very less, and the mass of the glacier will be very high, and it will be in between these two. Okay, the weight of the water body will be lesser than glacier, but it will be higher than wind. And again, speed. If you say the speed, velocity, so wind will have maximum velocity. Wind will have more velocity. Then next, we can say more velocity is running water. Then after running water, it will be glacier. So glacier moves very slowly. As we know, glacier moves very slowly. It takes long time to move from one place to another place. But wind, it moves very fastly from one region to from high pressure to low pressure. Wind moves very fast from high pressure to low pressure. And running water, they also move very speedily, but it depends. At a mountainous area, the speed will be high, and again in the plain and during the at this deltaic area, the speed will be slow. So if we apply this formula in different geomorphic agent, we can say that glacier will have the maximum kinetic energy. Why? Not in terms of velocity, but in terms of mass. The mass, the weight of the glacier is very high. It is very high compared to running water or wind, or even you can compare it with ocean current and sea waves. The glacier, the weight of the glacier is very high. When the glacier moves from one place to another place, because of the weight of the glacier, it causes stress on the rock surface. Because of the weight movement of this glacier in one direction, it will cause shearing stress on the surface of the rock, and because of that, it will pluck the rock debris. It will pluck the rock from the surface. It will do abrasion also. It will do plucking of the rocks and abrasion. Means it will remove it because of the resistance, because of the friction, high friction. Because of high weight means high friction, it will cause more friction. So it will pluck up more rocks and it will do lots of abrasion. And because of that, because of this high mass, though its velocity is low, because of its very high mass, the kinetic energy of glacier is maximum. So most of the most damage, which agent will do the most damage, it is glacier. Okay, compared to running water, wind, and others like groundwater and sea and waves, the maximum damage will be done by glacier because of this high mass. Now, what does erosion do? As we have already explained, erosion, the main motive of erosion is to bring the fragmented particles from one region to another region, from one region to another region. So, these fragments may be the result of weathering. These fragments may be the result of weathering. So, weathering help, it aids the process of erosion. Okay, erosion इस रॉक में अगर वेदरिंग नहीं हो रहा है तब भी इरोजन विल टेक प्लेस, तभी भी इरोजन होगा, लेकिन ज्यादा नहीं होगा जितने वेदरिंग में होता, थोड़ा कम जाएंगे फ्रेगमेंट्स. सो यहाँ से इरोजन होगा यहाँ पर, और एट द सेम टाइम यहाँ पर होगा डिपोजिशन. इरोजन एंड डिपोजिशन, तो दो जगह पर अलग अलग फीचर्स बनेंगे, लैंड फीचर्स बनेंगे, यहाँ पर इरोजनल लैंड फीचर्स बनेंगे, यहाँ पर डिपोजिशनल लैंड फीचर्स बनेंगे. So that is about erosion. So the next topic in the geomorphic process is mass movement, or you can say mass wasting. Now, as we have discussed till now, the different geomorphic processes, starting from weathering, we have seen in weathering things like physical, chemical, and biological. Okay, there will be physical changes and also chemical changes within the rock in case of weathering, and in case of erosion, the main force, that is erosional force of the geomorphic agents, comes from the kinetic energy because of the movement and weight of the moving object or particle. And here, next topic is mass movement. Mass movement. Here, mass movement, it takes place only because of the force of gravity. Gravity. Only gravitational force is responsible for the mass movement. Mass movement means movement of a huge debris of earth. A huge debris of earth when it will move from higher slope to the lower slope. Here, when these things will move from higher slope to lower slope, and who will act, which force will act here? Only gravity, because the gravity is pulling this debris towards the lower part of the slope. ठीक है, तो slope, it depends on the slope. The higher is the gradient, means high slope जितना steep होगा, the more is the slope steep of the slope, the more will be the mass movement. जितना steep होगा उतना ही mass movement ज्यादा होगा. As you keep on reducing the steepness, this is high steep, this is medium steep, then it is less steep. तो जितना हम लोग स्टेप को कमा के डाउन करेंगे, उसको रिड्यूस करेंगे उसको, उतना ही वो उसमें मास मूवमेंट कम होता होगा. तो यहाँ पर ग्रेविटी ज्यादा काम करेंगे, यहाँ पर थोड़ा कम काम करेंगे नीचे की तरफ, और यहाँ पर और थोड़ा कम करेंगे. और अगर जो फ्लैट होगा तो वहां पर ग्रेविटी मूवमेंट नहीं करेंगे, वहां पर इरोजनल प्रोसेस काम करेंगे ज्यादा. नाउ how we can divide as mass movements. Mass movement can be of different types. It can be fast. The mass movement can take place very fastly, and it can be very slow. It is debris can move from one place to another place very slowly. Okay, we cannot perceive it. It will take a long time. We have to observe it for a long time to see the effect of this mass movement. So mass movement can be slow and it can be fast also. Now we're going to talk about the slow, different types of slow and fast mass weathering. And before that, you have to know one concept called heap. Heap. So it is the slow movement or fast movement. We can categorize into heap, then flow, again slide. So if you see, if you observe, if we observe the mass movement, we can categorize it into heap, flow, and slide. Flow means it will flow like water. It will flow. The mass, the debris will flow like water. And slide, it will slide down along the slope. ये जो slope है, इस slope से वो slide down होगी इससे. But touching the slope, it will slide down along the slope. And another called fall. Another mass movement called fall. In fall, the hanging particles of rock, it will just fall down without touching the slope. Okay, hanging debris, earth debris like rock or mud, anything, this will come down by the act of gravity, but without touching the slope. And if it touches the slope while coming down, if it touches the slope of the hill, it will be known as sliding down. Then flow means it will flow from high slope to low slope, it will flow like water. Okay, so this we can categorize this mass movement according to movement into heave, flow, slide, and fall. And again, according to speed, we can categorize it into slow movement and fast movement. The first, just try to understand what is heave. What is the meaning of heave? So heave formation we can see mostly in the cold areas. Cold areas means mid latitude countries and or European countries. So what happens in the European countries? We can see ice, snowfall. Precipitation takes place in most of the European countries, cold countries, in the form of snowfall. See, these snows are there. Okay. Now what happened? These snows and this is the ground soil. This is the surface soil. This is the underground soil. These are the soils underground. We are taking the vertically we are taking a cross section. We are looking at the cross section of the soil. So there will be soil beneath the surface also, and there will be water molecule here also. You can find water molecule inside the soil also, underground soil also. Under the surface soil, beneath the soil, you can find water molecules inside there. So waters are here in the form of liquid, and the water here at the surface of the soil in cold areas, in cold countries, you can find in the form of ice. So what will happen, these water molecules, because of conduction, through the process of conduction, you know what is conduction, right? Conduction means transfer of energy. When two things keeps in touch with each other, they transfer energy. It may be heat energy, electrical energy, or any kind of energies. In case of heat energy, if a warm hot object touches a cold object, the hot object will transfer the heat energy to the cold object, and the cold object will increase its temperature. So until and unless it comes in equilibrium with the temperature, then it will be the transfer of energy will keep taking place. And once they become equal, the temperature of both the object becomes equal, then there will be no more flow of heat energy. Now what happens in this case, as you can say that the this ice, they will have low temperature. Ice will have low temperature, less than 0 degrees Celsius, suppose minus 2 degrees Celsius here, and it will be around, suppose 5 degrees Celsius here. These water molecules here, suppose they are having temperature around 5 degrees Celsius, and the ice particles over the surface of the soil, they will have temperature at around minus 2 degrees Celsius. Now what will happen next? There will be transfer of heat energy from these water molecules towards the ice. Towards the ice, there will be transfer of heat energy. And because of this conduction process, the water molecule here also will become cool down. The water molecules will cool down. The temperature will reduce because it is emitting the energy, heat energy. So the temperature here in the water molecules will reduce. Suppose the temperature has become minus 1 degree Celsius here of these water molecules. Now what will happen? These water molecules will become ice. These water molecules within the soils will become ice. And as we know, ice expands. Ice, the volume of ice is more. The density of ice is less than the density of water. So the volume of ice will be more than the volume of water, liquid water. So what will happen next? Because the volume of ice is more than liquid water, these ice particles here now, because this water molecules has got converted into ice, so they will expand now. These water molecules will expand. They will expand here, and because of this expansion of this ice inside the soil, they will push the soil molecules. They'll push the soil towards the upper part. They'll push the soil towards the upper part, and because of that, there is a movement of the soil. There will be a movement of the surface soil. जो surface soil है वो यहाँ पर कहीं कहीं उठ के आएंगे यहाँ पर, क्योंकि ये जो water ice है, ice को push कर रहा है because of expansion. The volume has increased, because of that it is expanding, and for that reason some part of the surface soil will expand, and this kind of movement of the earth surface is known as heave. It is known as heave. And we can see heap formation in this European countries, most of the cold European countries, and it is kind of disaster in the European countries. It can damage roads, it can damage buildings, and many properties. It can damage many properties. If there is a building here, it will get damaged, it will fall down. So this is heap. Now we have already explained what is flow and slide and fall. Now again, within this mass movement is because of gravity. It is taking place only because of the force of gravity. Now see, we can categorize this mass movement to slow movement, where we cannot perceive the movement. We have to observe the movement for a long time. We can see the result, but we cannot see the changes. Then again, this slow movement can be categorized into creep, and solifluction. Solifluction. Now what is creep? Creep is the slow movement of earth debris and soil. It can be a soil particle. Suppose these are made up of soil. It can be also fragments of rocks, small fragments of rocks. These particles may be also small fragments of rocks, or it can be soil particles also. So when these small fragments of rocks, we also call it talus. So you can find talus creep, you can find soil creep, Okay, so it can be soil creep or it can be talus creep. Now what happens here, these soil particles they keep moving very slowly in one direction. Okay, and this kind of slow movement of the particles of whether it may be soil or it may be talus, it this movement, slow movement, is known as creep. Now how we can observe it? If you see the telephone booth in your villages, if you see the telephone booth or you can see any electric tower, now after some time what happens, it start to hang. This was the original position and after some time it will start to hang in this side after a very long time. After few years you can find that the originally the portion of the tower or the booth, you can say that telephone tower, okay, telephone tower or electric tower, the original position of the tower was in this position vertically, but after few years you can find this position in this manner, it is hanging. Why it is hanging? Because the soil over where it is present, this soil is moving slowly in this direction, and this is a perfect example of creep. This kind of slow movement is known as creep. The next is solifluction. Now again, solifluction you can again find in mostly in cold areas. Now what happens in solifluction? Suppose this is a landmass. Here you can find ice, deposition of ice because of snowfall. And this snowfall ice, what will happen? They will wet the surface soil. They will wet the surface soil. जैसे सरफेस सॉइल है वो वेट हो जाएंगे, वो ठीक है, भीग जाएंगे वो, और सरफेस सॉइल जो है इससे नीचे पानी जाते रहेंगे नीचे, और एक टाइम आएगा कि इट कैन नॉट एब्जॉर्ब एनी मोर वाटर टुवर्ड्स द डाउन साइड, नीचे और पानी और नहीं जाएंगे उसके बाद। तब क्या होगा, जब नीचे पानी जाना बंद हो जाएंगे तो ये कम्प्लीटली भीग जाएंगे, इट विल बिकम कम्प्लीटली वेट, एंड दिस वेट particles of soil will start to move in a lower slope, जहाँ पर स्लोप नीचे की तरफ वो मूवमेंट करेंगे, धीरे धीरे मूवमेंट करेंगे वो, ठीक है। दिस स्लो मूवमेंट, why it is taking place? Because of gravity. It was a low slope, the gravity is pulling it, and because of that this slow movement is known as solifluction. These are two examples of creep, and solifluction are the example of slow movement. Now the next movement are known as fast movement. Again, the fast movement, it is also happening because of gravity, and here the movement we can see it, we can observe it, it is very fast. For example, earth flow, mud flow, then debris avalanche. So these are example of fast mass movement. Now what happens in earth flow? Especially in the humid areas, in the tropical countries where there is enough rainfall. Well, you can see that in the higher slope, because of very high rainfall, this earth material will get wet. This earth debris, soil or any fragmented rocks will become wet, and because of this, they because of because they have got wet, the weight of their weight of the particles will increase because they are absorbing water molecules, and because of that the weight of this soil particles will increase, and because of that we can see very fastly they are moving towards the downslope. They will move this earth debris, whether it can be soil or this one fragments, rock fragments, they will move very fastly towards the downslope. This kind of movement is known as earth flow, and it will be faster when there is less vegetation, when there is less vegetation. तो तुम आप लोग पहाड़ में देख सकते हो, पहाड़ के ऊपर देख सकते हो कभी कभी बहुत ज्यादा मिट्टी बारिश के टाइम में ऊपर से बहुत सारा मिट्टी नीचे गिर जाता है। क्यों होता है वो? क्योंकि इसमें कभी कभी हम लोग डिफोरेस्टेशन करते हैं, यहाँ पर झूमिंग कल्टीवेशन कल्टीवेशन होता है पहाड़ के ऊपर, कभी भी आपका कोई स्लैश एंड बर्निंग कल्टीवेशन बोलते हैं, और अदर ट्रांस ह्यूमन एक्टिविटीज की वजह से वहाँ पर जब घास वगैरह कम हो जाता है और दूसरा प्लांट्स भी कम हो जाता है, फिर क्या लूज हो जाता है, पानी मिलते ही बारिश होते ही इसमें लूज हो जाता है और सडनली वो नीचे की तरफ गिर पड़ते हैं, क्योंकि वो ग्रेविटी इसमें काम कर रहे हैं। This is a fast movement, okay, moving very fastly. This kind of movement is known as earth flow. Now what is mud flow? Mud flow is nothing but like earth flow only, but here the particles will be very small. In mud flow the particles will be very small, okay. It's like moving running, it's like a running water only, stream running, like a stream, like a moving water only. but they will contain lots of solute, lots of clays, lots of fine earth particles or soil. So this mud flow, mostly you can find mud flow in the volcanic areas, in the volcanic areas. Okay, see what the volcanic areas do, they release lots of debris, pyroclastic debris, then they release lots of ash and other pyroclastic debris. Then when rainfall takes place here in this area, what will happen, it will bring, this water will dissolve, not dissolve, it will bring all this ash and this mud along with it, and it will flow in the downslope. So you can find mud flow mostly in the desert area, not desert, sorry, volcanic areas. In the volcanic areas you can find lots of mud flow because of the presence of ashes and other debris. The rainfall will acquire these debris and it will bring to some other places in the form of stream. It will move in the form of stream like a mud flow, like a water. It will move like a water, but it will bring lots of mud along with it, and it is very harmful. It can do lots of damage. It can break down because of the force it will have. It will have the force of both the energy, both the kinetic energy of the water and the shearing force of the particles, soil particles. So it will hit anything, will be hit by this mud flow, will get damaged or it will be destroyed. And next is debris avalanche. Now as we know what is avalanche, avalanche is the when an earthquake takes place in the mountainous area, these ice caps they flow towards the downslope. But in case of debris avalanche, it is not taking place in this mountainous area. It will take place in the humid tropical area only. But what is the difference is that in the hilly areas, through a narrow zone, through a narrow zone, the debris will flow because of high rainfall. Because of high rainfall in the humid areas, this debris, earth materials will flow towards the downslope through a narrow zone. It is not going to cover all this area. It will flow through a narrow zone, and this kind of flow is known as debris avalanche. Another fast movement is landslide. And landslide is very common, mostly in the countries like India and other tropical countries where the rainfall is high and where we are losing the natural vegetation. Now, what is landslide? Landslide is actually sliding of the debris only, but compared to the other movement what we have discussed, in landslides the particles will be relatively dry. It will be relatively dry compared to the other movements. The particles here will be relatively dry. It will be relatively dry, the particles in landslide. Again, the landslide we can categorize into different types like slump. Now, what is slump? In this kind of landslide, the the debris will move from a higher region to lower region, but it will move with a back rotation. It will move with a back rotation. Suppose this was the original area. These are the plants. Okay, here this is the original area, and when it will there will be a landslide, this portion will move towards the downslope, but with a backward rotation. Suppose it is moving, it has reached here, so the portion of the plants will be like this. So they are moving, but with a backward rotation. So this kind of movement is known as slump, and it will reach here. When it will reach here, the plants will be in this position. Okay, so they are moving with a backward rotation. This kind of movement is known as slump. And when there is no backward rotation, it is known as debris slide. When there is no backward rotation, suppose this landmass is falling down here and there is without a backward rotation, then it will be known as debris slide. Okay, with a backward rotation, it will be known as slump, and without backward rotation, it will be known as debris slide. Then again, debris fall. Slide, you remember one thing, in slide they will touch the slope. They will fall down by touching the slope only. Okay, they will roll around this slope. But in case of fall, they are not going to touch the slope. They will fall freely. They will be free fall. Okay. So if the debris are falling down without touching the slope, towards the downside, that will be known as debris fall. Debris fall without touching the slope. And if they fall down by touching the slope, rolling down the slope, then that will be known as debris slide. Then again, we can find rock fall. Rock fall here. Rocks will fall down from one part to the lower part, from higher part to lower part, without touching the slope. They are known as rock fall. And if these rocks fall down by rolling around the slope, then it will be known as rock slide. The one thing you have to remember is the slide means it will touch the slope while moving down, and in fall it will fall freely without touching anything. So the damage that will be caused by fall will be very high because it will have lots of energy, and while during the slide it is releasing the energy. The amount of energy will be little bit less compared to the fall. So these are the different types of mass movements. Now you can find a question why we can find lots of landslide. We can find lots of landslide in the Himalayan region compared to the South Indian peninsular mountains. So if you compare the amount of the frequency of landslide in the Himalayas, it is more than the frequency of landslide in the peninsular mountains in the southern western Ghat. What is the reason? हिमालय में ज्यादा क्यों होते हैं लैंडस्लाइड, खासकर उत्तराखंड एरिया में, हिमाचल, उत्तराखंड, अरुणाचल, सिक्किम, ये सब रीजन में ज्यादा लैंडस्लाइड होते हैं. लेकिन अगर आप नीलगिरी हिल्स में जाओगे साउथ इंडिया में, पेनिनसुलर में, वेस्टर्न घाट, वहां पर लैंडस्लाइड होता है, ऐसा नहीं कि नहीं होता है, बट लेकिन कम होता है. पेनिनसुलर माउंटेन्स में कम होते हैं. रीजन क्या है? बिकॉज हिमालयस दे आर टेक्टोनिकली एक्टिव. these are tectonically active. Means the plates, the tectonic plates here are active. As we know, the Indian plate is hitting the Eurasian plate, and it is still moving towards the northern side. It is still moving towards the northern side, and the Himalayas being forming now. It is being forming now. The Himalayas जो है अभी भी बन रहा है वो, ठीक है, और ऊपर बहुत अभी भी जा रहा है वो, लंबा भी हो रहा है और बढ़ भी रहा है. Because of that, it is tectonically active. और जब tectonically active हुआ, there will be movement, shaking of the earth. We can find lots of earthquake because of this tectonically active nature of Himalaya. We can find lots of earthquake in Himalaya. That is one reason for lots of landslide we can find in the Himalayan region. Another is that sedimentary deposit, sedimentation. The rocks are mostly made because of sedimentation of the, that is say, while the India is moving towards the northern side, it has brought lots of sediments and it has uplifted the Himalaya. So Himalayas are mostly made up of sedimentary rocks. And as you know, sedimentary rocks are weak rocks compared to igneous rock and metamorphic rocks. They are weak rocks, so we can find landslides in this region. Then, if you compare with the peninsular mountains, they are tectonically stable. There will be earthquake, but it is not in a very high frequency. So they are tectonically stable compared to Himalaya. So वहाँ पर ज़्यादा shaking नहीं होगा. The next thing is that they are mostly made up of igneous rock. As we know, the southern peninsula is made because of the outpouring of lava. The southern peninsular rock or the southern peninsular plateau is made because of the outpouring of lava. And the lava, what the rock they make igneous rock. And the igneous rock are hard. Igneous rock, granite rock. Granite is an example of igneous rock. So granitic, they are mostly granitic, and granitic rocks are hard. So we can find less amount of landslide in the peninsular areas compared to the Himalayan areas. The next topic is soil. Soil. As everyone knows what is soil, and we have seen soil in every day-to-day life. Now, everybody has different way to define soil. But the people who do study about soil, they are known as pedologists. The science of soil is pedology. The science of soil is pedology, and the people those who study soils, they are known as pedologists. So as I have said, everybody have a different way to define soil. But according to these people, pedologists, how they define soil? The pedologists define the soil as living living particles, or you can say debris. Living particles are debris. They are living in nature. Why they are living? Because they contain lots of organic materials. Organic. They define soil as a living particles or living art debris, art surface, because they contain lots of organic materials in the form of dead or living, dead or living plants and animals. The soils will contain lots of living, dead or living plants and animals, and this living, dead or living plants and animals from the organic part of the upper layer, and they make soil. So according to them, the soil is dynamic. It keeps on changing. The surface soil keeps on changing. It is dynamic. You cannot find the same soil over a very long period of time. The soil will change here. Even you can take the example from Rajasthan. It is full of natural vegetation. There are lots of in the western part of Rajasthan, in Jaisalmer, where we can find desert now. In the beginning it was full of natural vegetation, but later, since we have got lots of fossils from this Rajasthan, we can say that it was full of natural vegetation. But later what happened, we can see now that it is full of desert sand particles now. So they're dynamic, they keeps on changing. And who will do these changes? It will be done by different environmental agents, denudation, erosional agents like chemical weathering, chemicals, biological, physical. All these things will keep on acting. Physical forces, biological forces, and chemical forces, they're acting every time on this surface soil. So they are dynamic, they will keep on changing. After a long time, we can see a change over the surface soil. So soil is dynamic, and it should have the capacity, it should be capable to support the growth of plants. According to pedologists, the soil should have the capacity to support the growth of plants. Now the formation of soil. The formation of soil is known as pedogenesis. Pedogenesis is the term we use for the formation of soil. Genesis means origin, formation. Okay, pedogenesis. Now this is the formation of soil. As we know how soils are formed, the first step in the formation of soil will be weathering. This is the importance of weathering. Weathering will be first step in the formation of soil. So a rock, we cannot say a rock is a soil. A rock is not a soil. To form a soil, first these rocks have to be weathered. And how it will be weathered? By this again, chemical, physical, and biological weathering processes. And once they get fragmented, these fragments will be brought by running water, glacier, or any wind, or we can say groundwater, sea waves and currents. They will bring it and deposit in some other places. So here, both at the erosional side, and at the depositional side, we can see the formation of soil. Now, how soil will form? Suppose these are the fragments. It can take place in the deposition side also, at the erosional side also. So about the fragments, what will happen? Bacterial growth will take place. Bacterial growth will take place, and other small microbial plants like lichens, mosses, they will grow there. These plants, small plants, when they will grow, and when the bacteria will make their colonies there, they will release some acids, humic acids. So these acids, they will loosen up these particles again. They lose up the particles here. Then again, we can find the birds or the water body, they can bring pollens or seeds. They can bring seeds from another place, and these seeds, when these birds will throw this seed over this area, in this deposition area, this seed will form plants again. They will give us to small plants like bushes. Then again, big, small, then larger plants will grow up here. Then again, animals will come. Small animals like rodents. Rodents, for example, mice, rat, then rabbits. They will come here and they will make holes here. These rabbits, rodents, and other rodents, they will make holes here. And because of the formation of these holes, the inside part will be again exposed. So there will be more and more bacterial growth inside, and again it will become more and more loose. The soil particle will become loosen up more. And again, other animals like earthworm. Earthworm is very important for the formation of soil. Why? Because earthworm, what they do, they eat up the soil and they make a fertile soil. They release a fertile kind of soil. Okay, so they will again lose up the soil. This atom will lose up the soil. Again, this plant roots, these roots will go inside the holes. The plant roots will go inside the holes and they will crack down more. So this area will become porous. Okay, you can find lots of holes here, porous. So when we can find more porous, more holes within these soil particles, so there will be exchange of air, exchange of water, then exchange of chemicals also, and they will make the loose more fertile, and it will help to grow more and more natural vegetation, more and more plants, and other animals will go there. Even human beings also go there later, and they get settled there. So that is how soils are formed. That is the process of formation of soil. This process is known as pedogenesis. Now we'll talk about the factors that are responsible for the formation of soil. The factors that are responsible for the formation of soil. There are different factors that will be responsible for the formation of soil. The first one will be parent rock. Parent rock, the rock from where this soil is going to be formed. So the most at the rock, there will be cracks within the rock. Okay. So how much cracks are there within the rock? How much fault is there? What is the chemical composition of the rock? Whether it is limestone or any other granitic rock, all these things depends. These are the things that depends on of the parent rock. So the parent rock is a passive control, passive factor. It do not participate directly in the formation of soil. The rock is a passive factor in the formation of soil. So we depend on the composition of the soil, chemical constitution of the soil, how much cracks are there within this rock, chemical composition of the rock, from this permeability of the rock. All these things will depend on the in the formation of soil. So this is the first factor, parent rock. The next factor is topography. Again, topography is a passive factor, means it do not involve directly. Now, what do you mean by topography? The different land features like mountains, plateau, all these areas. The nature of their arrangement over the surface of the earth. There will be some mountains, then plateau area, plain area. So these are topography of a region. The topography of a region also depends in the formation of soil. So in some area there will be more sunlight. In some area there will be more sunlight. This area, plain area, there will be more sunlight in the tropical area. So in the tropical area there will be more sunlight. So in this region we can find more weathering. This chemical, biological, and physical weathering will be more active here. So this is how topography also help. The next is if you see in the cold areas, cold areas, see cold areas में क्या होगा, यूरोपियन कंट्रीज में ये ट्रॉपिकल एरिया है, वहां पर सनलाइट सिर्फ साउदर्न स्लोप पे आएगा. जो साउदर्न स्लोप है जो है सनलाइट सिर्फ यहीं पे आएगा, इस तरफ नहीं आएगा सॉइल, इस तरफ सनलाइट नहीं आएगा. ठीक है, दिस इज अ ट्रॉपिकल एरिया, तो सनलाइट विल बी लिमिटेड. सॉरी, आई एम ड्राइंग हियर. Suppose this is a hill area in European countries, in mid latitude or high latitude countries. Here sunlight will fall only in the, suppose this is a southern slope, this is a northern slope, this is a northern pole. In this side we can find northern pole, this side southern pole. So in the southern slope we can find more sunlight, but in the northern pole there will be no sunlight. So because of this topography, the formation of soil here will be different from the formation of soil here will be from compared to this region. Okay. Now again the amount of precipitation also depends on the formation of soil. How much precipitation is taking place, how much rainfall is taking place. As we know there will be more rainfall in the tropical area, so the formation of soil will be fast in the tropical area compared to the cold areas near the polar areas. So these are the topographical region. One more important topographical factor is running water. Running water. So places where we can find more running water because of the topography of the place. It may be plateau, it may be mountainous area. So in the mountainous area, you can find lots of running water. So there will be the formation of soil will be fast because they will do lots of erosion and deposition features. So this is how topography participate in the formation of soil. Next is climate. And when we talk about climate, it again we talk about heat or temperature and precipitation. Heat and precipitation, not temperature. How temperature will, the climatic factor like climatic elements of heat and precipitation will act in the formation of soil. More is the heat, more is the temperature, more is the rate of physical weathering or chemical weathering. So as you increase the amount of temperature and water, the rate of chemical reaction increases. As you increase the amount of temperature and water to a chemical reaction, the speed increases. Speed of the chemical reaction increases. So in the tropical areas, again, we can find more heat and more precipitation. So in the tropical areas, the rate of formation of soil will be more because the rate of weathering will be more. That is the reason. Now again, in the precipitation, in the form of precipitation, if there is high amount of rainfall taking place over an area, then what will happen? It will erode lots of the minerals from the upper part and will deposit in some other part. Minerals will be eroded by the high rainfall because of high precipitation. Again, while moving towards the downside, this water body, it will bring lots of minerals from the upper part towards the lower part. This zone is known as eluviation. Eluviation, and this is eluviation. From here, these minerals will be removed and it will be deposited in the some other in the lower part of the soil. So these things are also responsible for the formation of the soil, surface soil. That is how climate affect the formation of soil. The next is biological activity. How biological activity is another factor in the formation of soil. Biological activity, like the activity of different types of bacteria, organisms, rodents, even animal, human activities, they also help in the formation of soil. Now, what they do? These rodents, as I've already explained, they make holes, and that holes actually within the rock exposes the inside part of the rock into the other chemical and physical weathering agents. These holes will expose these particles made by these rodents, rats and mice. It will be exposed to the other chemical and weathering agents, and it will damage this one rock from within the rock, within the crack. So that is how it biological activity helps. Again, this again root will go inside. It will again push exert pressure within the rock. Again, it will help in the breakdown of the rock. Human activities, different types of human economic activities like transhuman activities, grazing, grazing of our animals. So they also help in the breaking down of the rock. Okay. Then some of the bacteria like rhizobium, what they do, these bacteria, they absorb the nitrogen from the atmosphere and it provide the nitrogen. They fix the nitrogen and it provide the nitrogen to the plants. Okay, you can find rhizobium in the leguminous plants. They are in the symbiotic relationship with the leguminous plant. This rhizobium, they actually capture the nitrogen from the atmosphere and they provide it to the plants. So all this biological activity helps in this loosening up of this rock, helps in the breaking down of the rock, and ultimately it will help in the formation of the soil. And the last but not the least factor is the time. Time, as we give more and more time in the formation of soil, the soil will be more mature. Okay, if the soil is forming, then within years, few years, within 1 year, suppose a new soil has formed. So this soil will not be mature soil, it is a young soil. So this is not very much fertile, we cannot grow different types of plants here. But if the soil is old, suppose it is 50 years old, so this soil will be mature. We can find different horizons here. Profile, okay, we can categorize vertically the soil into different profiles. O horizon, A horizon, B horizon, like that. Upper part is organic, you can find lots of organic particles here. Humus content will be here. Then all these things will help in the grow of plants, different types of plants. So and even different types of organisms, animals will be there. So time, it depends on the time. More the time we give in the formation of soil, more will be the soil matured. Okay, as more time we provide for the formation of the soil, the soil will be more matured, and the less time we are providing for the formation of soil, the soil will be young. We cannot find in the young soil, we cannot find more profile. There will be one or two profile only in the young soils. So mostly in the polar areas, in the tundra region, ice cap region, we can find young soil. It has less activity, erosional activity. Because of that, we can find more young soil in the tundra area or ice cap area. And in the tropical area, again, we can find more profile. The soils are having more amount of profile. We can find different horizons of the soil We can divide the soil horizontally into different profile. So more is the profile, more will be the soil mature. So these are the different factors in the formation of soil. So this is the end of this today's class. We'll continue the next class again. And if you have liked this classes, and if you have any other inquiry, you can put it in the comment section. We'll try to give the answer. We'll try to give the solution. And please subscribe to the channel and share it. Thank you so much.